In this video we are going to look at the combined gas law. Now consider we've already looked at Boyle's law, we investigated Charles's law, and we also looked at gay-lussacs law. Now if we just do a visual inspection here, you'll notice that the pressure term appears up top twice, the volume term appears up top twice, and the temperature terms are on the bottom twice. So we can actually roll this all together into one giant law that we like to call the combined gas law. The way these questions work is you'll be given 5 of the variables and asked to solve for the 6th one. So here's a typical question. We have a 1 liter cylinder filled at 0.08 atmospheres at 20 degrees Celsius and is heated to 35 degrees Celsius, and the pressure has changed to 0.1 atmospheres. What is the new volume? So my first recommendation is you sort through the values in the question. Note that these 3 are together, and we are using atmospheres for pressure, which is fine. Both of our terms are in atmospheres, so we can proceed. If one were in atmospheres and one were in kilopascals, we have to change one of them. We just need to be consistent. So down here we've got 0.8 atmospheres, we have a volume of 1, and our temperature is 20 degrees, but of course we want to work in kelvins. So that becomes 293.15 kelvins. Over to our second, our pressure here, we again have 0.1 atmospheres. We're trying to solve for our V2, and we'll take the 35 degrees and add it to 273.15, and that gives us 308.15. So these are the values we're going to proceed with to our equation. So cleaning this up, there's our equation. We're going to take all those assigned values and substitute them in, just like that. And there's the exact same equation as well. Now, we're going to have to simplify this. So the way it's going to work is we're going to multiply the tops against the bottoms. So we're going to take those terms together, and we're going to multiply them by those terms. So there are all the ones we circled with the box, and there are all the terms we put as a circle. And all we're going to need to do is essentially we're going to divide both sides by this stuff here. So also divide on this side, and you can grab your calculator and start typing it in, and if you've done this properly you should get an answer of 8.41. Now, what are the units on this volume? So back up at the top here, we had 1 liter, so liters is what we were using. So liters is going to be the unit for V2. So let's tackle another one here with a few more wrinkles in it. We've got a 450 ml cylinder of gas filled at 0.8 atmospheres and 20 degrees Celsius. What is the new volume at SATP? So again, we'll take our variables here. These 3 terms are going to go together. So we have a pressure of 0.8. We have a volume of 450 mils. Now you can convert this to liters, that's fine. Or you can realize that in the second part we're calculating our volume, so all that means is that our answer is going to come out in terms of milliliters, which is absolutely fine. Our temperature is 20. We'll add our 273 to that, 0.15, so there's our Kelvin temperature. Now let's not forget the conditions with SATP. We have a pressure of 100 kilopascals, and we have a temperature of 298.15. Now we do have a problem here though, is that this value is in atmospheres and this was in kilopascals, which isn't going to work for us. So we're going to need to convert here. So we're going to go ahead here and let's convert this value here. So I'm going to have to do it right up here at the top here. So we've got 0.8 times, let's put 1 atmosphere on the bottom and 101.3 kilopascals up top, and that's going to work out to, I think, a little more than 84. So we're going to have 84 kilopascals here. So these are going to be the terms that we're going to proceed with now. So there's our gas law. There is our terms that we're putting in. Again, we're going to do some cross multiplying here. We're going to take the top and multiply by the bottom. Those will go together, and then that top and that bottom will go together as well. So there's all the terms written there. So to solve this one, it looks like we're going to divide both sides by 100 and 298.15. Cancel, cancel. So that also gets divided by 100 and 293.15. If you type all this into your calculator, you end up with 370.1, and again the units is going to be milliliters here, and if you get that value, then you have done it properly.